Okay, so here we are talking about normal distribution. So a normal distribution is just a special kind of way to distribute the values in a data set. It's actually pretty common, it shows up a lot. So it's actually a data set where the mean, median, and mode are all the exact same. And it typically takes the shape of a bell curve. You might have heard of that phrase before. So when you draw your frequency diagram, it takes the shape of a bell. Okay, so you might ask, well, does the bell curve always have to look exactly like that? Well, no. It could be a steep bell curve, or it could be one that's a little bit flatter, maybe a bit like that, maybe, or even, somewhere in the middle. Okay, so how steep your bell curve is really determined by how spread out your data set is. So the steepness, or the spread, is determined by the standard deviation of the data set, because the standard deviation of a data set explicitly tells you how spread out the values are. A higher standard deviation means that the values are more spread out. A lower standard deviation means that the values aren't as spread. So as a result, a higher standard deviation means more spread out data. So as a result, the bell curve will be flatter. Okay? However, a lower standard deviation means they're more clustered together, close together. So that'll result in a steeper bell curve. So in this case, I've got a pretty steep curve here. This could be a standard deviation of 20, whereas this flatter bell curve might have a standard deviation of 2. I've got those backwards actually. So this would be a standard deviation of 2. It's close together, so a small standard deviation. This one's more spread out, so my standard deviation is 20. Okay? Larger standard deviation, more spread, flatter the curve. Alright, so when it comes to standard deviations, normal distributions, we mentioned that our mean is always directly in the middle here. Alright, and we know that the spread is determined by the standard deviation. So what I can do is I can say, okay, if my mean is here in the middle, to the right, that means my value should be higher than the mean. So I'm going to divide the sections of the bell curve up in different sections. The first section here is going to be between the mean, and this would be one standard deviation above the mean. So it could be written like this: the mean plus one standard deviation. So that would be this section right there. So it would really be that area in that little spot. The next section would be right here. So this would be one standard deviation above the mean. I go another standard deviation up, so this would be the mean plus two standard deviations right here. And that would be this area right here. Okay? Let's go up at least one more, so this would be the mean plus three standard deviations. That would be that area right there. Okay? And then we can go the opposite direction as well. So this one right here, if I go down a standard deviation, would be the mean minus one standard deviation. That would be that area right there. This would be the mean minus two standard deviations. That area right there. And this would be the mean minus three standard deviations. That area right there. So what you should see is that it's a very symmetrical shape, right? So you might notice that whatever happens on this side of the curve also happens over here, right? Alright, when it comes to this spread here, you might notice that this area is the same as this area, okay? And it also doesn't matter what my mean is or what my standard deviation is. This area and this area will always be equal, and these areas will always be 34% of the data values right here in this little section. So that means this section right here would also consist of 34% of all of the data values. Okay? Likewise, over here you've got this area here, which looks about, well, forgive my drawing, but it looks about the same as this area here. And it also covers the same amount of area every time for every normal distribution. And it is 13.5% in here. and then 13.5% in here. And likewise the same thing here. So this would cover 2.35% of the data and 2.35% of the data. Okay? Now, you might notice that if I add all of these numbers up, I don't actually get 100%. And that should make sense because I have a little bit left on these outsides, right? If you add all of these up, it actually gives you 99.7%. So that would mean that between this section here and this section here, you've got 0.3%, right? So if this section and this section are 0.3%, and so 0.30, we can think of it as 0.30, then each section should have 0.15%. Okay? So within 3 standard deviations of the mean, that means between 3 standard deviations below the mean and 3 standard deviations above the mean, I have 99.7% of the data. Okay? You might also notice that if you look at page 278, that they show you that within 2 standard deviations of the mean, you've got 95% of the data, and within 1 standard deviation, you've got 68% of the data. Of course, you don't need to memorize these numbers because you can find them from up here, right? It's pretty easy to see that if you know that these are 34, then between that section would be 68% of the data, right? Okay? So now let's look at how we can apply this. So let's say I gave you the mean of a data set. Let's say it's 70. And my standard deviation is 4. Okay? I can actually draw the normal curve and label it based on those 2 numbers. So I'll draw my normal curve. I know that my mean goes right in the middle, so the 70 goes there. My standard deviation is 4, so that means that these intervals down here are going to be width of 4. So my first interval here is going to be 70 plus 4. So this would be a 74. So between 70 and 74. My next interval, add 4 more, would be up to 78. Then up to 82, etc., right? Then going the other direction, I would subtract my standard deviation. So this would be 66, 62, and 58. They do continue, but I recommend drawing at least what we showed in the previous diagram, so that's within 3 standard deviations both ways, right? Okay, so now with that said, I know what the spread is going to look like, right? I can fill these values in once I have these drawn. So I know that between 70 and 74, I'm going to have 34% of the data. Same between 66 and 70. Between 74 and 78, I'm going to have 13.5% of the data. Same between 62 and 66. Between 78 and 82, I'm going to have 2.35% of the data, the same as between 58 and 62. Okay. So with this drawn now, I could ask you what percentage of the data falls in any of these ranges, right? So I could say what percent of the data falls between 62 and 82. Okay? So all I would have to do then is say, okay, 62 is right here, 82 is up here. So all I would need to do is add up these numbers that are right here, right? So I would say it would be 13.5 plus 34 plus 34 plus 13.5 plus 2.35. Okay? And then I just add all of those numbers up. So that would be 97.35, I think. You can double check that number there. But that's essentially how you can use a normal distribution to find out what percentage of the data falls within a certain range. Another question is they could ask what percent less than 66. Okay? So 66 is right here, right? So I know that it would be 13.5 with 2.35, and then I've got this little bit right here. Well, remember, how do I find this little bit if I don't remember it? Well, I do know that within 3 standard deviations, I've got 99.7% of the data. That means I've got 0.30% of the data left between this section and this section. So 0.30 is shared between 2 sections, so that means this would be 0.15%, as we just discovered. So I'd have to add these 3 numbers to answer this question here. So it would be 0.15 plus 2.35 plus 13.5. So that is 2.5 plus 13.5. So that's what 16%. Okay.